Hello, my name is Anudeep and our presentation topic is zero shot learning. Firstly, when discussing why we chose this topic, imagine we were tasked with designing the latest and greatest machine learning models that can classify all animals in the world. Using our machine learning knowledge, we immediately understand that we need a labeled dataset with at least one example for every single animal. This contains more than 1000k described species in the world. So we're gonna need a data set roughly more than 2 million different classes. As we were probably noticed by now, getting large quantities of high quality labeled data is hard. It doesn't help when there are more classes that our model has to learn. So how do we solve this problem? One way is decreasing our model's reliance on labeled data. This is a motivation behind zero-shot learning, in which our model learns how to classify classes that it hasn't seen before. When we move on to the introduction to zero shot learning is a machine learning paradigm that enables AI models to classify data points into unseen categories without any training examples from those categories. This is a constraint to traditional supervised learning, where the model is trained on a set of labeled data points from all the categories that it will be asked to classify. The field of zero-shot learning is a difficult endeavor, and it holds the power to transform the landscape of AI systems. Imagine AI models that can accurately identify diseases from medical images or translate text into new languages, all without the burden of gathering and labeling extensive datasets for every new category. Such possibilities showcase the true potential of zero-shot learning and its ability to revolutionize the way we approach and utilize AI. Several methods exist for zero-shot learning, but they all rely on semantic embedding to represent data and category labels. Semantic embeddings are numerical vectors that convey the meaning of words, phrases, or images. By embedding both data and labels in the same semantic space, zero-shot learning models can learn to connect them even without prior training data for a specific category. A common approach in zero-shot learning is to utilize a semantic similarity matrix to compare the embeddings of the data points with those of the category labels. Subsequently, the data point is categorized under the label that bears the closest embedding. Alternatively, zero-shot learning can also employ a generative model to generate training data for the unseen categories. This involves training the model on data points from the seen categories and using it to generate synthetic data for the unseen ones. In the existing world of machine learning, there is a groundbreaking approach that yields impressive results. Zero-shot learning methods trains a model to not only recognize and comprehend known classes or concepts, but also handle new ones that were never seen in its training process. Take natural language processing as an example. It involves training a model to interpret and categorize text into classes it wasn't initially taught. Zero-shot learning has the potential to revolutionize various fields such as medical diagnosis, machine translation, customer service, and recommendation systems. It enables the development of intelligent AI systems that can perform tasks without the need for large data sets or labeled data. These tasks include diagnosing new diseases, translating text into different languages, answering customer questions about new products and services, and recommending products and services to users. With the use of zero-shot learning models, The need for the time-consuming data collection and labeling is eliminated, making these systems more efficient and accurate. Zero-shot classification refers to the problem setting where we want to recognize objects from classes that our model has not seen during training. In zero-shot learning, the data consists of seen classes, unseen classes, and auxiliary information. Seen classes are classes for which we have labeled images during training. Unseen classes are classes for which labeled images are not present during the training phase. Auxiliary information is the information consists of descriptions or thematic attributes or word embeddings for both seen and unseen classes at train time. This information acts as a bridge between seen and unseen classes. To fully grasp the zero-shot paradigm and develop effective solutions, it is crucial to first confront the major challenges of zero-shot recognition. These challenges implicate the performance of our models in zero-shot classification. Methods used in zero-shot learning are semantic embeddings, attribute-based approaches, word-image coloration, transfer learning, structured knowledge graphs, generative models, hybrid models, data augmentation and synthesis, ontologies and taxonomies. Zero-shot learning methods used in NLP and computer vision are transfer learning and human generalization, zero-shot learning role in detecting unseen classes, addressing the lack of labeled data, zero-shot learning in computer vision for image classification, zero-shot learning in NLP, tackling complex text classification problems, zero-shot learning for text classification, Janet AI's approach, the effectiveness of pre-trained models like BERT and Robert, zero-shot learning for sentiment analysis.
Hello, this is Andrea Lakshya Sabastikarma. I am going to cover the unlocking power of zero-shot learning in NLP and computer vision. First, we'll start with transfer learning and human generalization. Actually, transfer learning is a concept in a machine learning that draws inspiration from human generalization, which is just as human apply their existing knowledge to understanding new situation. Transfer learning allows machines to leverage prior knowledge to tackle new tasks. For example, it's like an AI to ride a bicycle after it has already learned how to ride a skateboard. So, this ability to transfer knowledge is what makes AI more adaptable and efficient in a rapidly evolving world. Next, we'll zero shot learning detecting unseen classes. Zero shot learning is a groundbreaking concept that empowers machines to make inference about entirely new classes without the need for labeled examples. This remarkable ability to akin human cognitive capability where we can apply our own existing knowledge to understand and categorize new concepts that we have never encountered before. For example, it's just like a baby can recognize a new breed of dog even if they have only seen other type of dog before. ZSL allows AI to classify objects it has never seen. It expands the horizon of what AI can achieve, making it more adaptable and versatile than ever before. Now, addressing the data scarcity. In the realm of machine learning, the scarcity of labeled data is a persistent challenge. Collecting and annotating data for every possible classes or categories is often impractical, time consuming, and even costly. But here is where zero shot learning comes to the rescue. Actually, CSR serves as an effective solution to this issue by enabling models to extend their capabilities to unforeseen categories. It reduces the reliance on extensive labeled data set and allows AI to adapt and learn more quickly. Next, we'll start with ZSL in computer vision. Zero-shot learning has made significant contribution in the field of computer vision, particularly in image classification. Zero-shot learning empowers models to recognize and classify objects or scenes they have never encountered during training. A key aspect of CSL in computer vision is to establish a semantic relationship between known and unknown classes, which is seen and unseen classes. It's like a teaching a computer to understand that a cat and a lynx and both are fill-ins. even if the fetus has only seen images of domestic cats during their training. Now let's get into tackling text classification challenges. Text classification in NLP presents unique complexity, making it a fascinating yet integrated task. These complexities include ambiguity, context dependency, and the ever evolving nature of language. But in the world of NLP, zero shot learning models have stepped up to the plate. ZSL model tackles these challenges by identifying patterns between the semantic and future space of text and their associated labels. Zero-shot learning is transforming text classification, make it more adaptable and capable of handling the integrated nature of human language. Next, ZSL for text classification in 8 R's approach. In the realm of zero-shot learning for text classification, an innovative approach was proposed by Yin and their team. Their approach bridged together the power of textual entitlement and leveraged pre-trained models for natural language interference. But what makes this technique stand out? It enables a classification of text into categories that were not seen during the training phase. By employing textual entailment, the model can determine if a given text can be entailed by the hypothesis, indicating a match between the text and the class it's been tested against. This method harnesses the power of NLI pre-trained models, making it highly effective for zero-shot text classification tasks. In 8 Al's approach showcase how innovation is pushing the boundary of what's possible in the world of text classification and zero-shot learning. Now we'll get into pre-trained models, Brett and Robretta. In the world of zero-shot learning for text classification, pre-trained models like Brett and Robretta have emerged as true champions. What set them apart in their remarkable effectiveness? These models are trained on a vast corpus of text, allowing them to encode a deep understanding of language. In the context of CSL, they excel in capturing the nonsense of text and its relationship with various categories, even if those categories were never seen during their training. This contextual embedding they provide significantly enhance the CSL process. The improvement translates to higher accuracy and ability in various natural language processing tasks. Brett and Roberta are the unsung heroes behind many CSL success, and they continue to push the boundaries of what possible in NLP. Finally, CSL in sentiment analysis. Zero-shot learning has made remarkable strides in the field of sentiment analysis. It's not just recognizing positive or negative sentiments, it's about understanding and generalizing sentiments for unseen classes. This ability is essential because language and sentiment expressions continuously evolve in the real world context. In the dynamic environment, CSL ability to categorize and analyze sentiment even for classes it has been seen during training become invaluable. It ensures accurate and up-to-date insights into people's opinion and emotions. CSL is not just analyzing sentiments, it's keep pace with the ever-changing landscape of human emotions. Finally, as our presentation draws to the close, it's clear that zero shot learning is more than just concept, it's transformative force in the world of artificial intelligence. We have explored how ZSL allows machines to leverage peer knowledge, detect unseen classes, addressing data scarcity, and conquer text classification challenges. That's it. Thank you so much.
I'm Vaishnavi Dolipodi. I am master student in Florida Atlantic University. Now, I am here to conclude the discussions on zero shot learning. This will encompass key points, the benefits of zero shot learning, its applications, and future works. The core idea behind zero shot learning is to enable predictions and classifications for classes or categories that the models have never encountered during their training. Let's dive into the exciting world of natural language processing, where rapid progress is being made thanks to groundbreaking technologies like transformers and models like BERT. Traditional machine learning often struggles with the high cost of label data. That's where zero shot learning comes into a play. It's a powerful concept that helps us tackle the challenges of working with unseen classes in NLP. Zero shot learning acts like a bridge between what we know and what we have never seen before, making it super useful for real world NLP problems. Imagine zero shot learning in sentiment analysis as a quick learner of languages and emotions. It adapts rapidly to new sentiments, giving us accurate insights even for categories it's never come across. One big deal about zero shot learning is that it reduces our need for loads of labeled data. We are talking about relying less on extensive datasets, right? And to top it off, zero shot learning teams up with pre trained models like BERT and Roberta, helping us understand text nuances and connections across different categories. So, zero shot learning is not just a concept, it's a game changer. Exciting, right? Now, we will see the benefits of zero shot learning. Zero shot learning is like a game changer in machine learning. It helps us in a few important ways. First of all, it reduces the need for loads of label data, which can save time and money. It allows our models to quickly adapt to new things they have never seen before, which is super handy in real world situations where things keep changing. It's also a great for working with different languages, helping with translation and finding information even when we don't have a lot of data for those languages. So, in a nutshell, zero shot learning makes things simpler, faster, and more flexible in the world of artificial intelligence. Now, we will see the benefits of zero shot learning. Zero shot learning is like a game changer in machine learning. It helps us in a few important ways. First of all, it reduces the need for loads of label data, which can save time and money. It allows our models to quickly adapt to new things they have never seen before, which is super handy in real world situations where things keep changing. It's also a great for working with different languages, helping with translation and finding information even when we don't have a lot of data for those languages. So, in a nutshell, zero shot learning makes things simpler, faster, and more flexible in the world of artificial intelligence. As I mentioned earlier, these are the explanations for cross lingual information retrieval, medical diagnosis, recommendation system, customer services, language translations, and anomaly detection. Let's step into the future with zero shot learning. This incredible approach has some exciting applications. First of all, there is the mind reading concept. In this fascinating world, zero shot learning joins forces with advanced tech like functional MRI. Each data point is a brain scan, and words define categories. Zero shot learning deciphers brain patterns, opening doors in a healthcare and brain computer interfaces. Next, we have a audio recognition. Zero shot learning helps models understand new sounds with a small text guide. Instead of guessing sounds, it predicts sound features like vowels and consonants for accurate recognition. Lastly, drone vision. Zero shot learning is not just for a new things. It's also about adapting to different solutions like in drones also. It helps drones recognize objects in changing real life scenes. Exciting, right? Thank you so much for giving this opportunity.